AP Calculus First Semester Exam Problems 17, 20, and 21. These three problems, 17, 20, and 21, will work on this lesson from the semester exam or from the calculator portion of the test. So that's the focus of this video lesson, calculator usage and problem solving. Problem 17, a particle moves along the x-axis so that at any time t is greater than or equal to 0. Its velocity is given by v of t equals 3 plus 4.1 times the cosine of 0.9t. What is the acceleration of the particle at time t equals 4? Let's look at what makes this a calculator problem. After differentiating, we'll get negative 0.9 times 4.1 times the sine of 0.9 times 4, or the sine of 3.6. The sine of 3.6 is not one of the 16 points on the unit circle we need to know the values for. So that's the big thing that makes this one a calculator problem. And with a calculator, one way we could do this is find the first derivative of the velocity to give us acceleration, then substitute 4 for t. But fortunately, this calculator, the TI-Nspire CX, will do it all for us, including the differentiating. First, we go to a calculator mode. It's the lower left icon here. And here's our calculator view. And pressing the menu key in the upper right portion of the keypad, this is what we get, the menu view. And with the menu view, here's the calculus option, option number 4. And we can go to the calculus submenu by scrolling down and pressing enter, or by pressing the number 4 key. And since we want the numerical derivative at a point, we press 1 or enter, and this is what we get. We are given the default variable x, which we could change to t if we wanted to, but we can go ahead and use x instead of t. It will be fewer keystrokes for us. Next, we tab down to value and enter the number we're evaluating, and it's 4 for t. And we're taking the first derivative, so we leave the default value of first derivative in place. Then we tab down to OK, then press enter, and this we get our derivative all set up. Now we enter the function we want to differentiate, and that's 3 plus 4.1 cosine of 0.9x. Press enter. We have our acceleration of 1.6329, which we box in and circle our correct answer, C. Problem 20. Let f be the function with derivative given by f prime of x equals the sine of quantity x squared plus 1. How many relative extrema does f have on the interval x is greater than 2 and less than 4? And we have our 5 answer choices below. The best way to do this, I think, is to graph f prime of x and then to do our evaluation. Here's f prime of x entered in our function editor, and when we press enter, this is what it looks like. We need to examine the interval here between 2 and 4, and it's pretty crowded. We can't see it very well in this dimension, in this viewing dimension here, so we're going to change that. So what we do is we'll change the window to see what's going on a lot better. First we look at the menu view. Next we look at the window zoom, option 4. Then we choose window zoom by pressing 4 or scrolling down and hitting enter. And this is the window zoom menu. And press enter to get the window settings. Since we're evaluating the interval between x equals 2 and x equals 4, that's what I've changed the x min and x max to here on the settings. And to see the x-axis better, we'll change the y minimum to -2 and the y maximum to 2. And now to look at the graph, we'll tab down to OK and press enter. So now we have a good look at the function over the relevant interval, from 2 to 4. And when we see relative extrema, how many relative extrema do we have here? Well, we have 3 of them. But here's the problem with this diagnosis. This function being graphed is not f of x, but rather f prime of x, or the first derivative. And so the number of relative extrema is determined by the graph of f prime of x crossing the x-axis to go from negative to positive, which represent minimums, and also the graphs going from positive to negative would represent maximums. So now here are all the changes in sign of f prime of x circled, and these x values represent the inputs related to the extrema or extremes for the function f of x. So our correct answer is D. Problem 21. The function f has first derivative given by f prime of x equals the square root of x over 1 plus x cubed. What is the x coordinate of the inflection point of the graph of f? And we have our answer choices A through E. To do this problem, we need to have the understanding of how to find an inflection point. A point of inflection is found, or can be found, where the second derivative of a function is equal to 0. I know of a couple different ways to do this one. The way we'll look at first is to find where the slope of this first derivative function is 0. But first, a little more analysis. Since we have the square root of x in the numerator, that means that our x-coordinate cannot be less than 0 because there is no real number whose square root is a negative number. So we can cross off answer choice D since it's an impossible answer. Here's the function entered in our calculator and graphed. To better evaluate where our point of inflection is, we would be better off to take a closer look at the critical part of the graph boxed in red here. And here are the window settings we'll use to take a better view of that graph. That's x min equals 0 and x max equals 2, y min equals 0 and y max equals 1. Tabbing down and clicking OK, this is what we get. And this high point of f prime of x, where the slope of the graph is 0, the maximum of the graph, where the slope of the graph changes from positive to negative, represents the x-coordinate where we have our point of inflection. And to find this maximum, we'll go first to Menu. We'll go next to Analyze Graph, option number 6. And pressing 6, this is what we get, the Analyze Graph submenu. And since we're looking for a maximum, here is where it is on our graph, option number 3. And we get to that option by pressing 3, and we see the lower bound vertical dashed line at the far left of the view screen. We press enter and set the lower bound, and the calculator now asks us for the upper bound. Using the touchpad, scroll to the right of the maximum so the vertical line is over to the right. We can already see the maximum highlighted before pressing enter. Press enter. We have the x-coordinate of our maximum here, 0.473. And we circle our correct answer, B. And I did mention that there's another way I know of to do this as well. It's going to go back to the calculus application. We'll go to numerical derivative at a point, and we'll choose for a point to evaluate answer B, 0.473. Now we tab down to OK and press enter. Next, we'll enter what we need to differentiate here right after the ddx. Now here is the function entered. Press enter. We get negative 0.000618 down in the 10,000th place, very close to 0, which confirms our correct answer B. This has been AP Calculus First Semester Exam Problems 17, 20, and 21. Thanks for viewing.